going to discuss about. My name is Vamsi Krishna, Assistant Professor ad hoc, Department of Physics, AKNU, Rajahmundry. So today I am going to discuss about FET. Means field emission transistor. You might know that BJT is the bipolar junction transistor. FET is the field effect transistor. In BJT, you have three terminals. Yes, same as in FET also, you have the three terminals. In BJT, the three terminals are collector, base, emitter. Okay. In FET, you have the three terminals. The name, its name is drain, source, and gate. Okay. Here in BJT, the IB is the base current, which is the input current, and also it's a controllable current to the BJT. Okay. So the BJT, we call it as a current control device. Okay. This FET device is controlled by the voltage between the gate and source. That's why the BJT FET we call it as the voltage control device. Okay. So whatever the applications is applied to the BJT is also applied to the FET. So BJT is the current control device because the IB is the base current which is control the whole device of a BJT. Okay. So IC is the output current which is depend upon the input current. So whereas in the FET means field effect transistor, ID is the dependent on the voltage VGS. So output current is dependent on the variable voltage of between gate and source. Therefore, FET is, we call it as voltage control device. So BJT is the bipolar device. Why we call it a bipolar? Polar means here, bi means two, polar means the charges. Okay, means in BJT device you have the both electrons and holes. It depends upon the both electrons and holes, but in FET it's a unipolar, means only either the electrons or holes. Okay, for conduction of the electricity. FET can have both N channel and P channel FET. In N channel, the majority part will be the N channel. In N channel FET, the majority part will be the N channel. In P channel, the majority part will be the in P channel FET. The majority part is the P channel, P type material. Okay, you know that N channel FET, the majority carriers are electrons. In P type P channel FET, the electrons are the holes are the majority carriers. FET can be used as amplification and switching operation devices. So FET is classified into the two types. So one is JFET and the other one is MOSFET. JFET is the junction field effect transistor. I repeat, JFET is the junction field effect transistor. MOSFET is the metal oxide semiconductor field effect transistor. Okay. Again, MOSFET is divided into the two types, which what we call as a depletion MOSFET and enhancement MOSFET. The FET is also classified into the two types. The one is N channel JFET and another one is P channel JFET. FET have input impedance compared with the JFET have high input impedance compared with the, sorry, okay, please write here, FET have the high input impedance compared with the BJT. The FET are more temperature stability, have more temperature stability than BJT. FET is a very smaller device compared with the BJT. Then BJT is very sensitive to applied signals as compared with FET. So let us now to know about the construction and working of JFET. So here I'm going to discuss about N-channel JFET. So majority part will be the N-type material. So P in in JFET you have the two depletion layers formed by the two P-type materials. So one depletion layer is formed between the left side of the P-type and P and between the P-type material and N-type material. The another depletion layer is formed between the right side of P-type material and N-type material. So, okay, this depletion layer is controlled by the external voltage is applied to the between drain and source, and also the gate terminal and at the source terminal. Okay. So this is the construction of these JFET. So this is the this MOS this type this MOS this JFET is the P type P channel, means why we call P channel means there is a channel between, there is a connection between drain and source. That connection is the major part is the P type material. The major part of the channel between the channel drain and source, that's why we call it as ఈ డ్రైన్కి సోర్స్ మధ్యన మెయిన్గా ఉన్న పార్ట్ ఏంటంటే, సో దట్స్ ఏ పీ టైప్ మెటీరియల్. దట్స్ వై వీ కాల్ ఇట్ యాజ్ P channel JFET. If it is there is a channel between means there is a connection between the and drain and source. If it is a N type material, then we call it as N channel JFET. Okay. So as I said before, in JFET there are two PN junctions from N channel JFET. The first junction formed between P and N of the left side and the same as the right side. Because of the two PN junctions, the JFET has the two depletion layers. As I said before, there is no free charge carriers in the depletion region. Why the depletion layer doesn't why the depletion layer cannot have the free charge carriers? Because of the electrons are combined with holes, so the atom is neutralized. The atom will become neutralized, so there is no free charges in the depletion region. So if we increase the width of the depletion region, if we want to increase the width of the depletion region, then width of the channel will reduce. So if you want to increase the width of this width of this depletion regions, the channel width will be decreases. The width if you want to increase the width of the depletion region, the channel width will be decreases. So has shown like this. So as shown here. So if you want to increase the depletion width of the depletion region, then the channel width will be decreases. This will be achieved by the connecting potential difference between the drain and source. Okay, it will be achieved in the reverse bias condition. Okay, therefore there is obstruction in the flow of, if the channel width is decreases, if the channel width is decreases, there is no flow of electrons. So consider one water pipe. Okay, so if the water pipe, if you press if you press this water pipe in any way of anywhere. Okay, so then the flow of water will be decreases. If you release that water pipe, then the flow of the water will come out, whatever the water will come out from that water pipe will increases. So you know that you already experienced that. Okay, so you know that water pipe, right? This whatever we use for. So you have a water pipe. The water is flowing into the water pipe as like from the drain to the source. Drain is the here tap. The source is what we call is as water. The water is coming out of this water pipe. So if you pressed water pipe anywhere in that water pipe, so the flow of water will be decreases at the end of the water pipe. So when we release it, the flow of water is increases. So same like here, same analogy is applied here. So if you increase the width of the depletion layer, the flow of electrons will be decreases. Therefore, there is obstruction in the flow of electrons when the drain and source terminals are connected to the potential difference. Because of the potential difference, the free electrons in the n channel is drifted. So we will see the working of this. So the conventional current ID will flow from the drain to the source. So the current will flow from ID. Whatever the current flowing ID, conventional current will flow from ID to I. The current ID is flow from drain to source. So conventional current ID will flow towards the source. We can control the width of the depletion region using the gate terminal. So we can control the flow of electrons using the gate terminal. That's why we can call the JFET is the voltage control device. So this width of the depletion region is depend upon mainly on the gate and source terminals, the potential at voltage, the gate and source terminals. Okay, that's why we call it as the voltage control device. So let's see the working of this JFET. So there are the working of the JFET divided into the two cases. One is in case one, between the potential difference between the gate and source will be same. Okay, so second case is the potential difference between the gate terminal and the source terminal will be less than 0 volts. For both cases, the VDS, whatever the VDS means potential difference between the between the drain and source is the positive voltage. Okay, so voltage between the drain terminal and source terminal is positive, so VDS is greater than 0. So let us talk about case 1 first, then later we will talk about the case 2. Okay, so when we apply we are applying the 0 potential at voltage at the gate and source. That's why we connected this gate terminal and source terminal to the ground. Okay, so we have to apply the VDS. Then it's not a VDD. so VDS. Okay, so this VDS is the potential at drain and the source. Okay, we have given the positive terminal to the drain and negative terminal to the ground. So okay, so let us assume that so now we are increasing the, so the you if you observe here, in this diagram, in this figure, the positive terminal is connected to the N channel, so negative terminal is connected to the P channel, so it is in the reverse biased condition. I repeat, positive terminal is connected to the N channel, the gate terminal is connected to the P channel, so it is in the reverse bias condition. Why? Because the when we said that the device in the forward bias, the positive terminal should be connected to the P type material, and the negative terminal of the battery is should connected to the N type material. Then we call this configuration, this type of arrangement, we call it as forward biased configuration. So when it is reversed, means negative terminal is connected to the, means lower potential is connected to the P type material, high potential is connected to the N type material, then we call it as reverse bias condition. So the drain is connected to the positive terminal, source is connected to the negative terminal. Because of this region, electrons in the N channel. So you know that the negative terminal is, so in N channel the majority carriers are charge carriers are electrons. So electrons, the negative terminal is connected to the source. So whatever the electrons in the N channel get repulsions between negative terminal of the battery and the electrons in the N channel. So electrons will drift towards the uh, drain terminal. So the electron will flow. So you have the higher potential at near the drain terminal. You have the less you have less voltage, means with we have less, we have thinner depletion region at near the source terminal because of the potential drop across the drain to source. Let us assume that you have connected the 2 volts power supply. 2 volts power supply. Let me read this thing. Electrons in the N channel will drift towards the drain, and electrons are being attracted to the positive charged drain. Conventional current ID moves from the drain to the source terminal. As long as the VDD is applied to the circuit, the width of the depletion level will be VDD remains constant at bottom, but remains at the bottom, but changes at the, so when we applied it, okay, then the width of the depletion layer will increase at the top, and will be it is not change at the bottom. Why? Because this N channel is providing resistance to the current flow. Okay, we can consider the N channel has this further resistance. So let us take D represents the drain current and S represents the source current. So you have applied the 2 volts between the drain to source. So at the source at source terminal you have 0 potential. At drain terminal you have that 2 volt power supply. Okay. So you have in between you have the 4, let us assume you have the 4 resistance. Okay. So that these all are in the series, so equivalent resistance will be 4R, and VDD is 2 volts. So the current means the voltage drop will be V is equal to IR. So current will be 0.5 volts, 2V is equal to 4R. So 2 volts is equal to 4R, so X is equal to R. So R is the 0.5. At each terminal, at each resistance, you have there is a 0.5 volts drop across that resistance. So now we can see the how potential VDD is divided across the N channel. The potential at a gate terminal is 0. So our first case is about the case 1 is about 0. VGS is equal to 0, means the potential at gate and source terminal will be 0. So we are applying the potential at the P channels of the at the both ends, at the both sides. Okay, so we are applying the 0 potential at the both sides, so at the same time. So now the potential gate terminal is 0, the potential near the depletion layer of the drain means here you have the 1.5 volts, next here 1 volt, here 0.5 volts, here 0.5 volts, here 0 volts. So this voltage will decreases from the drain to source due to the potential drop across the each resistance. So okay, so what I said was the high potential is connected to the N channel, and low potential is connected to the P channel, so it is in the reverse bias, so that the depletion layer is increases at the top and increases more at the top than the depletion than the bottom, because the potential is lower at the bottom. It has 0.5 volts at the bottom, it has 1.5 volts at the top. So the more depletion layer will increases at the top than the bottom. Okay, I hope you understand. So this is the way the potential different width of the depletion layer increases, so the flow of alkaline will decreases when we increases the potential between the drain and source. Therefore depletion layer will increases, because 1.5 volts is applied to the N type material, and 0 volts is which is less than the 1.5 volts is applied to the P type material. Now PN junction is definitely reverse bias condition, and when we increase the reverse bias, the depletion layer is also increases. If we see this 0 volts and 1.5 volts, definitely the reverse bias potential is lesser as compared to the 0 volts and the 1.5 volts. So the width of the depletion layer will increase, but not that much. So this was the reason, because the depletion layer is more at the top than the bottom. So this is the symbol of JFET. I have to mention this symbol of JFET at the beginning of this video, but I forgot to tell that this is a P type material, P channel JFET. The difference between P channel and N channel JFET symbol is here at the gate terminal, the gate current will flow out of the device, that is the P channel. If it is the current which is flowing inside the device, that we call it as N channel JFET. Okay. So let us know about the pinch off voltage. So as you know that so when we increases the voltage more than the 2 volts, then the depletion layer will increases at the top more. So if we increase the more and more, means more and more voltage between the drain and source, the depletion layer is also tend to touch each other. Okay. So ideally we thought that these two depletion layer will touch each other completely, means but it is not possible in real situations. Okay, but it is not true in the real. In the real, the two depletion regions will never touch each other. The channel will still have the width is very small. So because of this reason, the current density will is also increases. What is the reason of these the two depletion layers not touching each other? Because of this, so when we increases, the more potential will drop at the near the drain, like at here. Okay, so at here, so potential at the pinch of voltage will be the potential drop at the at a pinch of point will be 0. Okay, so the potential drop across the across this resistance and the voltage drop across the resistance of this resistance because of id, and when these two depletion level touch each other, id will become 0. The potential, so as I shown in the figure, the potential at the pinch of voltage is 0, potential at pinch of voltage at 0, and potential at the gate terminal is also 0. So at gate terminal and pinch of voltage point also, the both uh, potentials are 0. So depletion layer, without the depletion layer never get increase. So without the depletion wouldn't increases. So this is the graph between current output current id and vds. If we increase the vds, the current will flow increases. Okay, if increases vds, the ids is id current flow will also increases at particular point that is called pinch of voltage. So at particular pinch of voltage, the current will become saturation. So IDSS is a maximum current flow from between the drain to source. So the drain current for JFET when VGS is equal to 0 and VD, and between the two conditions we should apply the conditions. VDS is greater than mod VP. So thank you all. It is all about today, and I will send this PDF. Thank you. Be prepared. So చదవండి మొత్తం. సో యూ గాట్ మీకు ఎగ్జామ్ టైం టేబుల్ వచ్చింది కదా జూన్ 20th నుంచి. సో స్టార్ట్ ప్రిపేరింగ్. సో థ్యాంక్ యూ ఆల్. Meet you tomorrow.